Okay, so what do you think is the most important part of any AI system? I bet it's not what you think. It's not the super complex code or those powerful models we're always hearing about. Today, we're going to dig into what truly makes AI reliable, and, well, the answer might just surprise you.
All right, picture this. An AI makes a big mistake. Maybe a self-driving car gets something wrong, or a recommendation engine pushes out some really bad content. What's our first instinct? We immediately point fingers at the AI's brain, right? But what if we've been looking in completely the wrong place this whole time?
And this is where it gets really interesting. On one side, you've got the usual suspect, the model, the algorithm. We figure the code must be buggy. But the real culprit, the true weak link in almost all modern AI, is hiding in plain sight on the other side. It's the data. You have to remember, the information an AI learns from is its foundation, and if that foundation is shaky, the whole thing is going to come crashing down.
So that leads us right to the core of the problem. You see, unverified data isn't just some small annoyance. No, it's a full-blown disaster waiting to happen. It quietly plants these hidden risks deep inside the system that can totally sabotage an AI's performance and, frankly, its safety.
You can pretty much boil these risks down to three big buckets. First, the data can just be flat out wrong or full of bias. Second, it can be a total mess, inconsistent and chaotic. And third, it's often completely untraceable, a real black box of problems. Let's dig into each one.
Okay, this first one is a huge deal. If you feed an AI training data that has mistakes in it, you're literally teaching it to fail. Think about a medical AI learning to spot diseases from scans. One wrong label could have devastating consequences. And what's worse is that if the data has these systemic biases, the AI doesn't just learn them, it gobbles them up and then spits them back out amplified on a massive scale.
All right, next up, inconsistency. Imagine you're trying to teach an AI about fruit, but in your data, sometimes an apple is called red fruit, other times it's a Granny Smith, and sometimes it's just fruit. The AI has no idea what's going on. There's no standard language. This chaos just completely wrecks its ability to see clear patterns and learn anything useful.
And this one, oh man, this is an absolute nightmare for anyone trying to build this stuff. When your AI messes up, you've got to figure out why. But with unverified data, there's no paper trail. You have no idea where that specific piece of bad info came from. It's like trying to find one bad ingredient in a giant cake after it's already been baked. Good luck. Debugging becomes practically impossible.
So, we've established a problem, right? It's the data. So what's the solution? Well, it means we have to completely change the way we think about this. We need to stop obsessing over bigger, faster, more complex models and start focusing on the quality of the very foundation they're all built on. And that's really the heart of it all. The real breakthrough isn't going to come from tweaking an algorithm one more time. It's going to come from building that rock-solid foundation of verified data. Data that you know is structured, you know is trustworthy, and you know is transparent from the get-go.
Okay, so how do we actually do this? How do we build this foundation in the real world? Well, one really promising blueprint is what's called the Kadada Protocol, and it's built on three fundamental pillars of data integrity. It all comes down to these three key pillars. First, structured annotation to bring order to that chaos we talked about. Second, provenance tracking, so you have a complete history for every single data point. And third, a really clever system of economic incentives to make sure everyone involved has some skin in the game.
So that first pillar, structured annotation, this is our weapon against that inconsistency problem. By using a controlled vocabulary, basically a shared official dictionary of labels, everyone starts speaking the same language. Let's go back to that medical AI. Instead of one person labeling a scan as a tumor and another calling it a neoplasm, this ensures everyone uses the exact same precise term. Instantly, the data becomes coherent, organized, and way easier for the AI to learn from.
Pillar number 2 is all about playing detective. It's about traceability. Every single action, every upload, every label, every single correction gets recorded on an immutable ledger. Think of it like a permanent, unerasable record of everything that's ever happened to that piece of data. So for that medical scan, we know exactly who labeled it and when. If an error pops up, you can trace it right back to the source. The black box is God.
And this third pillar, this is where things get really, really clever. This is about aligning everyone's incentives. Basically, people who contribute data have to put a little money on the line, a stake, if you will, to vouch for the accuracy of their own work. If their data is good, they get rewarded. If it's bad, they lose that stake. It's a simple, powerful mechanism that naturally weeds out bad data and rewards high-quality contributions.
So what's the result of all this? What happens when you put these three pillars together? Well, you get a radical transformation. You go from an AI system that's built on a flawed, shaky foundation to one that is genuinely robust and seriously reliable.
I mean, just look at the difference here. On the left, that's the world of unverified data. It's erratic, it's chaotic, it's completely opaque. But on the right, with verified data, you get a system that's robust, coherent, and totally transparent. It's a total night and day difference.
And the benefits in the real world? They are absolutely massive. First off, your AI just gets tougher. It's more robust, so it can handle changes in the real world without just falling apart. Debugging becomes so much faster because you can actually trace errors back to their source. And for huge industries like finance and healthcare, it provides that clear, auditable data trail that regulators are starting to demand.
So if you take away just one thing from all of this, let it be this. True, reliable AI doesn't start at the very end of the process with a bunch of last-minute safety checks. It has to begin at the very source, with the foundation of verified, trustworthy data. Anything else is just a band-aid on a much bigger problem.
And that really leaves us with one final critical question, a question you should be asking whether you're building AI or just using it every day. Is the system you're relying on built on a foundation of sand, on unverified, chaotic, and opaque data? Or is it built on stone, a solid, verifiable, and transparent foundation of truth? Because the answer to that question is going to determine everything.